myself Ankush Haldkar. This course is based on safety in water tanks. Now first, the table of contents. Introduction of water tanks. Second, importance of safety in water tanks. Third, regulatory framework. Fourth, designing safe water tanks, materials and construction. Fifth, inspection and maintenance. Sixth, safety protocols and procedures. Seventh, emergency response. Eighth, case guides. 9. Environmental considerations. 10th, conclusions. 11th, Q&A, that is questions and answers. Now, introduction to water tanks. Number first, definition of water tanks. An introduction to water tanks serves as the foundation for understanding these essential structures. Water tanks plays a critical role in storing and distributing clean water for various purposes, ensuring a consistent and reliable water supply for communities, industries, and households. Second, purpose and uses. Address the importance of maintaining water quality and hygiene in water tanks, light measures to prevent contamination and ensure safe drinking water. Types of water tanks. Number first, elevated tanks. Number second, ground level tanks. Number third, underground tanks. Number four, portable tanks. Number fifth, industrial and commercial tanks. Now, importance of safety. Safety in water tanks is of paramount importance to protect both the water supply and the people who interact with the tanks. Water tanks are vital components of water supply systems used for sorting and distributing drinking water, firefighting water, industrial process water, and more. Ensuring safety in water tanks is crucial for several reasons. Number 1. Public health protection. Contaminated or unsafe water can lead to serious health risks, including waterborne diseases. Safety measures in water tanks help prevent contamination of water, the stored water, ensuring that it remains safe for consumption and other uses. Preventing waterborne disease. Waterborne disease such as cholera and dysentery can spread when water is not stored and handled safely. Properly sealed and maintained tanks reduce the risk of pathogens entering the water supply. Maintaining water quality. Safety measures such as tank lining or regular cleaning help maintaining water quality by preventing corrosion, sediment buildup and the growth of algae or bacteria inside the tank. Now, structural integrity. Ensuring the structural integrity of water tanks is crucial to prevent tank failures, which can result in catastrophic accidents, floodings, and damage to property, the environment. Now, fire safety. Some water tanks are dedicated to firefighting purposes. Ensuring their safety and functionality is essential to provide an adequate water supply in the event of a fire emergency. Now, worker safety. People involved in inspecting, maintaining, and repairing water tanks face potential hazards such as confined spaces, falls, and exposure to chemicals. Safety protocols and equipments are essential to protect workers. Now, environmental protection. Leaks or spills from water tanks can contaminate the environment, affecting soil and aquatic ecosystems. Proper contaminant and safety measures help prevent environmental damage. Now, compliance with regulations. Many regions have regulations and standards governing the design, construction, operation, and maintenance of water tanks. Compliance ensures that the tank meet safety requirements and legal obligations. Emergency preparedness. Water tanks often serve as emergency water reserves during natural disasters or other emergencies. Ensuring their safety and functionality is crucial for disaster preparedness and response. Now, community trust. Safe and reliable water storage and distribution systems build trust and confidence among the public. People rely on these systems for their daily needs, and any safety lapses can erode trust in the water supply provider. To ensure the safety in water tanks, it's important to implement a range of practices and measures, including irregular inspections, maintenance, and cleaning, as well as adherence to relevant safety standards and guidelines. Training personnel in safety procedures and emergency response protocols is also essential. Accidentally utilizing modern technology such as remote monitoring systems can help detect issue early and prevent safety incidents. Overall, prioritizing the safety in water tank is not only a legal and regulatory requirement but also a fundamental responsibility to protect public health, the environment, and the integrity of water supply system. The significance of safety in water tanks. A water tank is a container for storing water. They are used to provide storage of water for use in many applications such as drinking water, irrigation agriculture, fire suppression, and agriculture farming, both for plants and livestock, chemical manufacturing, food preparations, as well as many or other uses. Potential risks and hazards. Potential hazards vary widely, however, proper planning for any tank cleaning should cover risk mitigation strategies to reduce threats. Tank by nature are confined spaces. This creates unique challenges due to lack of air flow and light, as well as potential problems for workers entering and exiting tanks. Other hazards can include fires or explosions, toxic gas and vapor releases, oxygen shortages and physical danger, exposure to radiation and environmental contamination, among others. Regulatory framework. Overview of local and national regulations. Emphasize the significance of regulations in safeguarding public health, the environment, and infrastructure integrity. Highlight that water tank regulation aim to standardize practices and minimize risks. Next, compliance requirement. Next, discuss the role of local authorities such as city or municipal governments in regulating water tanks, mentioning that the local regulations often address zoning, land use, and construction permits. Next, designing safe water tanks. Next, Factors to consider in designing. Design and configurations. Standpipes, reservoirs and composite elevated tank CET. Design are the different types of configurations used when selecting glass coated bottled such as steel tanks, manufacturing process, coatings, tank construction, maintenance, lifetime value, flexibility, expandability, safety standards and guidelines. Provide an overview of key safety standards and guidelines commonly referenced in water tank design and construction such as AWWA D100 welded steel tank for water storage. Second is AWWA D110 wire and strand wound circular pre-stressed concrete water tanks. Third is API 650 welded tanks for oil storage relevant for some applications. Next, NFPA 22 standard for water tank for private fire protection. Now, materials and construction. Materials used in water tank construction describe the common materials used in water tank construction including concrete, steel, fiberglass, plastic that is polythene, wood that is less common wood, construction, best practices, formwork. Now, formwork is the temporary or permanent support structure mold into which concrete is poured. It is also known as centering or shuttering. You may ask why formwork is important. Formwork is important for concrete to harden in the desired shape and to gain strength and durability. Now, what is reinforcement? Reinforcement for concrete is provided by embedding deformed steel bars or welded wire fabric within freshly made concrete at the time of casting. The purpose of reinforcement is to provide additional strength to the concrete where it is needed. Now, concrete placement. How the concrete placement is going on? So, concrete placement is a critical step in the construction process involving the pouring, spreading and leveling of concrete to create structural elements like foundations, slabs, walls, columns and more. Proper concrete placement is essential to ensure the strength, durability and performance of the finished structure. Now, next is curing methods. Curing is a crucial step in the concrete construction process that involves maintaining adequate moisture, temperature and time conditions to allow the concrete to properly hydrate and gain strength. Proper curing enhances the durability, strength and longevity of concrete structures. There are various methods of curing of concrete and the choice of method depends on factors such as project requirements, environmental conditions and available resources. Now, welding procedures, quality control, tank cell assembly, wire winding or standard winding. Other is post tensioning. Post tensioning in which the tensioned wire are used with the combination of concrete structures. Now next, concrete placement. Now next, inspection and maintenance. In inspection and maintenance of water tanks are critical to ensure the continued functionality, safety and quality of stored water. Whether the tank is used for potable water supply, industrial process or firefighting or regular inspections and maintenance, helps preventing issues like leaks, contamination and structural failures. Here are guidelines for inspecting and maintaining of water tanks. Number 1, regular inspection. Other is irregular inspection. Number 1 is visual inspections. Conduct routine visual inspections of the water tanks, exterior and interior. Look for signs of wear, corrosion, cracking or damage. Pay attention to the following: paint or coating condition, structural integrity, weld and seams, access hatches and doors. Other is ventilation systems. Now next is roof inspection. Inspect the tank roof or cover for any damage or corrosion. Ensure it is secure and properly sealed to prevent contaminants and debris from entering the tank. Other is interior inspection. If safe and feasible, conduct interior inspections by entering the tank. Check for sediment buildup, corrosion and any sign of bacterial growth. Use proper safety equipment and procedures when entering confined spaces. Now next is overflow and drainage inspection. Ensure that overflow and drainage systems are functioning correctly. Verify that the tank overflow pipe is clear and unobstructed to prevent overflows during heavy rains. Now the next is water quality monitoring. Water quality sampling. Periodically collect water samples from the tank and test them for water quality parameters such as turbidity, pH, chlorine levels and microbial contaminations. This helps ensure that the stored water remains safe for its intended use. Inspect the tank for contaminants. Look up for signs of contaminants or foreign objects in the water, such as debris, algae or sediment. These can impact water quality and may require cleaning or filtration. Now maintenance. In maintenance, in which first point is cleaning. Regularly clean the interior of the tank to remove sediment, biofilm and other contaminants. The frequency of cleaning depends on factors like water quality, tank size and their uses. Use approved cleaning procedures and disinfection methods. Now, repainting or coating. If the tank protective coating is deteriorating, consider repainting and recoating the tank exterior to prevent corrosion and extend its lifespan. Now next is structural repairs. Address any structural issues promptly to prevent leaks or failures. Repair cracks, welds or seams as needed. Consult with a structural engineer if necessary. Now the next is valve and pipe maintenance. Replace or repair malfunctioning valves, pipes and fittings. Ensure proper sealing to prevent leaks. Now next is roof and cover. Roof and cover maintenance. Repair or replace damaged roofs or covers. Keep them securely fastened to prevent contaminations and debris entry. Access ladder and safety equipment. Ensure that access ladder and safety equipment such as handrails and fall protection are in good condition and meet safety standards. Now the next is record keeping. It is necessary to make a record so that maintenance time can be achieved. Maintain detailed records of inspections, maintenance activities, and water quality testing results, and any repair or modifications made to the tank. This documentation helps track the tank's history and compliance with regulations. Now the emergency response planning. Develop and maintain an emergency response plan in case of tank related incidents such as leaks or contamination events. Ensure that personnel are trained and equipped to respond effectively. Now the next is regular inspection and maintenance are essential for preserving the integrity and reliability of water tanks. Timely attention to issue and adherence to regulatory requirements are crucial to ensure the safety and quality of the stored water supply. Consulting with water tank specialists and engineers can provide valuable guidelines in implementing an effective inspection and maintenance program. Now, inlet and outlet inspection. Examine the inlet and outlet pipes and valves for leaks, corrosion or blockages. Ensure valves are operational and free from debris. Debris are the small particles which get settled in inlet and outlet of valves of the tank. Importance of regular inspection. Emphasizes the importance of quality control and inspection throughout the construction process. Discuss methods such as visual inspection, non-destructive testings and documentations. Maintain procedures. Acknowledge potential challenges in water tank construction. Discuss strategies to address challenges effectively. Common issue and red flags. Explain the final testing and commissioning phase, including hydrostatic testing, leak detection, and water quality checks. Discuss the importance of commissioning documentations. Safety protocols and procedures. In safety measures, safety for workers, emphasize the paramount importance of worker safety in water tank operations. Highlight the safe workers contribute to project success and reduce the risk of accidents. Next is operational safety. Operational safety is the safety which is done while the project is ongoing. Now, explain the importance of wearing appropriate PPE. PPE means public protective equipments, including hard hats, safety glasses, hearing protections, respiratory protections, gloves, high visibility clothing, fall protection gear, entry and confined space procedures. Entry and confined space procedures in which sufficient area so that no suffocation would be felt by worker. Explain the risks associated with confined space entry in water tanks. Describe the procedures for safe entry, including gas monitoring and ventilations. Now the emergency response. Developing an emergency action plan, that is EAP. First aids kits should contain a variety of supplies to treat common injuries and medical issues, including adhesive bandages, sterile gauge and dressings, antiseptic wipes, scissors and tweezers, disposable gloves, CPR face shield, pain reliever, example aspirin or other. Emergency contact numbers, basic first aid instructions, response procedures for contamination, leaks and structural issues. Describe emergency response procedures including first aid kits and first responders, fire extinguishers locations, evacuation plans, case studies, real world examples of water tanks incidents. Some of the real world examples of water tank incidents, both failures and successful safety measures had been taken. Number 1. Real world example of water tank incidents, both failure and safety successful measures provide valuable insight into the importance of safety practices in construction and maintenance of water tanks. Here are some examples. First example is Vajont Dam disaster, which happened in 1963 in Italy. The Vajont Dam experienced a catastrophic failure due to geological instability. A massive landslide caused a giant wave that overtopped the dams, resulting in the death of around 2,000 people. Failure cause: poor geological assessment and inadequate safety measures. Chicago water tank collapse, that is happened in 2009. A around 1.2 million gallon water tank in Chicago collapsed, sending debris crashing down onto a restaurant below. 2 people were killed and several others were injured. Failure cause is corrosion weakened the tank, supporting structure over time. Now the next example is Saluda Dam failure, which has happened in 1928. The Saluda Dam in South Carolina collapsed, leading to catastrophic flooding. The disaster resulted in insignificant loss of life and property. Failure cause is poor construction practices and inadequate maintenance. Now the next failure is Monroeville water tank renovation, that is failed in 2020. Monroeville, Pennsylvania renovated an aging water tank to extend its lifespan and ensure safety. The renovation project included structural upgrades and improved safety features. Success factors: these are the dams which are successfully saved. Proactive maintenance and safety focused renovations. Number 1 is Cedar Reservoir roof collapse, that is happened in 2015. In Seattle, Washington, the roof of a water tank at the Cedar Reservoir partially collapsed during heavy snowfall. No injuries occurred because worker had been excavated before the collapse. Success factor is proactive evacuation and safety protocols. Now the next is environmental consideration. Environmental impact assessment plays a major role in EIA. Environmental impact assessment is a systematic process used to evaluate the potential environmental effects and consequences of proposed projects, plans, programs, or policies before they are implemented. The primary goal of an EIA is to ensure that development activities are carried out in an environmentally sustainable manner. Here's an overview of the key components and steps involved in the environmental impact assessment. The process begins with scoping, where the project's boundaries and objectives are defined. Now second is key stakeholders, including government agencies, local communities and experts are identified and consulted. The scoping process helps determining the environmental factors will be assessed. EIA report, a detailed EIA report is prepared summarizing all the information gathered during the assessment process. The report includes a description of the project, baseline data, impact assessments, mitigation measures, alternative assessments, and the results of the public consultations. Now, what is the mitigation measures? Mitigation measures. Mitigation measures for water tanks are essential to minimize adverse environmental impacts, protect water quality, and ensure the safety and integrity of these structures. There are some safety considered in civil engineering. Safety is a paramount concern in civil engineering to protect the health and well-being of workers, the public, and the environment. Implementing safety measures is essential to prevent accidents, injuries, and damages during construction and maintenance projects. Here are some general safety principles and practices in civil engineering. Number 1. Compliance with regulations. Ensure that all projects adhere to local, national, and international safety regulations, codes, and standards. Stay updated with changes in safety guidelines and laws. Number 2 is risk assessments. Conduct thorough risk assessments before starting any project, identify potential hazards, and develop strategies to mitigate risks. Third is site safety plans. Develop and implement comprehensive site-specific safety plans for each project. These plans should outline safety procedures, emergency response plans, and their roles and responsibilities of workers and supervisors. Number 4 is training and education. Provide appropriate safety training for all workers and ensure they are knowledgeable about safety procedures. Equipment and hazards. These includes regular safety briefings and refresher courses. Number 5 is personal protective equipments, that is PPE. Ensure that all workers have access to and use the necessary PPE such as helmets, gloves, safety glasses, steel-toed boots, and high visibility clothing. Number 6 point is equipment safety. Regularly inspect and maintain construction equipment and machinery to ensure they are in good working order. Follow manufacturer guidelines for safe operations. Number 7 point is protection. Install fall protection systems such as guardrails, safety nets, or personal fall arrest systems where there is a risk of workers falling from heights. Number 8 point is traffic control. Implement proper traffic controls measures in construction zones to protect both workers and the public. This includes signage, barriers, and designated pedestrian walkways. Number 9 point is excavation safety. When working on excavations, follow safety guidelines for trenching and shoring to prevent caves in and protect workers. Number 10 point is material handling. Train workers on safe methods for handling, storing, and transporting construction materials to prevent accidents and injuries. 11th point is fire safety. Have fire prevention and firefighting equipments readily available on site. Conduct fire drills and ensure workers know how to use fire extinguishers. Emergency response. Develop and communicate clear emergency response plans for accidents, fires, and other emergencies. Ensure that all workers are aware of these plans. 13th point is environmental protection. Minimize the impact of construction activities on the environment by implementing erosion control measures, proper waste disposals, and hazardous materials management. 14th point is communications. promote effective communications among all project stakeholders, including workers, supervisors, and management, to address safety concerns and issue promptly. 15th point is continuous monitoring. Regularly inspect the worksite to identify and address safety hazards. Encourage workers to report unsafe conditions or behaviors. Now the 16th is behavior based on safety. Promote a cultural safety where workers take responsibility for their safety and the safety of others, regard safe behavior and address unsafe practices. 17th is safety committees. Establish safety committees or designated safety officers responsible for monitoring and improving safety on the construction site. 18th is documentation. Keep detailed records of safety, inspection, incidents, and training to track progress and identify areas for improvement. Number 19th point is review and improvement. Periodically review safety, performance, and incidents to identify where for improvement, make necessary adjustment to safety protocols and procedures. Remember that the safety is an ongoing process in civil engineering projects. It requires a commitment from everyone involved, from project managers and engineers to construction workers and subcontractors, to prioritize safety at all time. Now the conclusion of this course is that we have to summarize all the key points. Number second, safety is paramount in water tank management, and a proactive approach to safety measures and ongoing maintenance is crucial to prevent accidents, protect public health, and ensure the reliable supply of clean water. Emphasis on the importance of safety. Emphasizing the importance of safety is critical in any context, whether it's in the workplace, at home, or within the community. Safety ensures the well and being of individuals, the protection of property, and the sustainability of operation. Now this is the question and answer session. Open the floor for question and discussion. Thank you and have a nice day.